Welcome. This video is going to go over finding missing links of similar polygons. We're starting with some of the hard ones first, is where we have, instead of having two separate images that we're dealing with that are similar, we have a specific relationship that happens when you have triangles of this type. First of all, I want to comment about what's happening with these two angles right here. So I'm going to draw this line right here. This line is called an angle bisector. And what an angle bisector does, it takes whatever angle that it's constructed with and it cuts it literally in half. So for instance, if this angle here is total 60 degrees from there to there, these two pieces here both have to be 30. And what happens when you have a triangle that's cut by a angle bisector, it creates a relationship between the proportional relationship between these two sides and these two sides. Okay, so this is where the proportionality is going to come from, the statement right here. So we're going to say that that's x. I know this entire side is 3. This means this side has to be 3 minus x. Now when I write my proportionality statement, this is going to be on top, this is going to be on the bottom, and the same way for this side over here. This will become 2 over x equals 4 over 3x. Now just like I said in the notes, once you get to that point, you write your proportionality statement, then you go ahead and you solve the equation. So we'll do our cross multiplication of denominators. So 3 times 2 will give me, or that should be 3 minus x. So when I write my proportionality statement, I have 2 over x equals 4 over 3x. Now I'll go ahead and do my cross product like we talked about. So 2 times 4 would, or x times 4 will give me 4x. 3x minus 2 will give me 6x minus 2. Now we can go ahead and solve this. I want to get my x's to one side, so I need to add 2 to each side, 2x to each side. That'll give me 6 equals 6x. Divide each side by 6, so 1 equals x. This means that that side is 1 and that side is 2, so we have solved for x, and that's what it wanted us to do. Problem number 2 is of the same type, where you have a triangle cut by an angle bisector. This means that the 5 will be our numerator, the 2 will be a denominator. Our x that we're trying to find will be a numerator and denominators. This means I'll have 5 over 2 equals x over 4. Now go ahead and solve that, and you should have that one done. On problem number 4, it's more like what we've been used to, where we have a larger triangle. You can see that I have it drawn right here, and we have a smaller triangle. If we look at these two relationships, we can see that they're similar right off the bat, and we can see which sides are proportional. The 12 goes along with the small triangle, and we can see that 12 plus 8 will give me the 20 that I need for the larger triangle right here. This unknown x is right there, so this small triangle right here has to be 45 minus x. We're given on the big triangle this entire side is 45. With that being said, it's pretty easy to go ahead and finish this problem. Let's go ahead and write our proportions. So 20 new divided by the old, 20 over 12 will be equal to 45 over 45 minus x. Multiply these, cross multiply these together. 45 times 20, that should be 900. 900 minus 20x will be equal to 12 times 45. I think that should be 560. Let's go ahead and check that and make sure that's right. So 12 times 45. Yeah, 540. I'm glad I checked that. 540. Let's go ahead and erase that. Now that we've done our proportional statement, we've cross multiplied, we get our right equation. Now let's go ahead and solve this. I want to get the negative 20 by itself. Subtract 900 from each side. Negative 20x equals 540 minus 900, so 540 subtract 900. That'll give me a negative 360. Divide each side by a negative 20. That gives me x equals 18. So that little x there is 18. If I take 45 minus 18, that tells me that this little piece right here would be 27, if that's what they wanted to know as well. So on these two problems, there's you're supposed to state if two triangles are similar, and there's two ways that you prove similarity. The first one is that you show that two triangles have two congruent pairs of angles. Another one is just by showing that the sides are proportional. The first one, we're going to go for the idea of angles. Now, a long time ago, you should have learned in geometry that if we have two intersecting lines, they form what we call vertical angles. And opposite sides are vertical angles. So if I have that angle there and that angle there, those are vertical angles, and vertical angles are congruent. So a good way to approach this one to show similarity is simply to say that vertical angles are congruent. And label the angles. So we can see that angle C is congruent to angle D. You can see these marks here that shows us that. And then we see that angle GBH is congruent to angle CBD. Now that we have our two sets of congruent angles, we can write our congruency statement that says triangle BCD is similar to triangle GBH or BGH. There we go for that one. Now in number 10, we're going to do this a little bit different way. You can see here that I have two triangles. You can see that this side right here has a length of 48. This side right here has a length of 8. And now we can do our proportionality statements. Now remember, we have to do corresponding sides, so 66 over 11. So this big side over this corresponding side, so 66 over 11 has to be equal to 48 over 8. So you can see that each one of these sides are equivalent to 6. So that shows proportionality. And now our statement is triangle QRS is congruent to QGH. Okay, let's take a look at problem 16. It's kind of a different one. Here we're just supposed to solve for the missing side. So 14 will correspond to 7, so I'll write 14 divided by 7. And then we have to find the missing side here, so the x will be on top, and then 3 will be on the bottom. Go ahead and do your cross product. 3 times 14 would be, what, 42? Equals 7x. Now we divide each side by 7 to get x by itself, so x equals 6. So that's how you do the next 4. On 17 through 20, they kind of change things up a little bit. I think if you go through and read the text, it talks about the surface area of different figures. If they, you know, if two figures are similar, their surface areas will also be proportional. Let's take a look at 75. Now this is a new. Isn't that what we said up here? New is on the left, old is on the right. Let's go ahead and write this proportionality statement. So 75 will be on top and 108 will be on the bottom. Now because these things are proportional, I want to get back to the dimensions of their sides. We're dealing with a square yard, so I'm going to take the square root of each side, take the square root of the top, take the square root of the bottom, and then we'll just put that on our calculator and see what we get. The square root of 75. Make sure you close your parentheses while you do this. Square root of 108, that's a square, not a square root. Square root of 108. Fraction. So that relationship is 5/6. The important part of this is to be able to take the square root. So let's go ahead and do this one right here. Let's take 49. Let's say that that's the new and 36 is the old. We take the square root of each side. Square root of 49 is 7. Square root of 36 is 6. And so that would be my answer for 18.